Hi, welcome to lecture 10. In this lecture, we want to repeat what we did in the previous lecture, but this time for IPv6. Therefore, after this lecture, expect you to configure and basic troubleshooting for EIGRP for IPv6. Let's start our today's mission. Before we start our EIGRP for IPv6 configuration, let's compare EIGRP for IPv4 and EIGRP for IPv6. First, their similarities. Both of these protocols use protocol type number 88 in IP header. Both of them use the successor and feasible successor logic. Both of them use diffusing update algorithm. Both of them support VLSM. Both of them use only triggered updates and only changes informed after a full update. And finally, both of them use the same formula for metric calculation as we talked about it in the previous lecture. Now their differences. As you know that IPv6 uses the prefix and the length format for showing the IP. For example, 2001/1/64, and IPv4 uses the format of, for example, 192.168.0.0/255.255.255.0. Route advertisement in EIGRP for IPv6 is done through this format, and route advertisement for EIGRP for IPv4 is done through this format. Next hop IP address in EIGRP for IPv6 is the link local address of the neighboring router. We don't have any link local addresses in IPv4, therefore EIGRP for IPv4 only uses the primary IP address of the next router. Message encapsulation clearly in EIGRP for IPv6 done through IPv6 packets. EIGRP for IPv6 uses IPv6 packets for sending messages, and EIGRP for IPv4 sending messages through IPv4 packets. EIGRP for IPv4 supports automatic route summarization only if you use classful IP addresses in your networks, and EIGRP for IPv4 could do automatic route summarization at the boundaries. But in IPv6, we don't have any classes concepts. Therefore, IPv6 or EIGRP for IPv6 could not do automatic route summarizations in any format. If you don't know anything about route summarization, don't worry, I will tell you about this concept in a separate lecture. And finally, EIGRP for IPv6 is not sensitive about the IP address of the neighbors in forming neighborship relation. That if the IP address of the neighboring routers are not in the same subnet, EIGRP for IPv6 does not have any problem with this, and two routers could become neighbors. Now let's start our configuration, but before that, let me tell you something. Since I use 7200 router in my simulation, if you want to use my scenarios, you have to import this iOS into your GNS3 too. Now let's start our configuration from router 1. As you see, the network between host 1 and router 1 is 2001.001/64. So I have to put this IP address on my fast Ethernet 0/0 interface. Now I do it. Configure terminal, interface fast Ethernet 0/0, IPv6 address 001/2/64. I put the one IP address on the PC. Now let's do no shutdown, and I want to check it in my PC. Ping -6 2001/001/2, and I have the ping. Therefore, the connection is okay between the PC and the router. Now interface fast Ethernet 0, fast Ethernet 1/0 between router 1 and router 2. I want to configure this interface fast Ethernet 1/0, IPv6 address 2001/002/1/64, and no shutdown. And in router 2, configure terminal, interface fast Ethernet 1/0, IPv6 address 2001.002.2/64 and no shutdown. Let's check our connectivity. Ping 2001.002.1. The connection is okay. And the next interface of router 2, which is between router 2 and router 3, fast Ethernet 1/1, IPv6 address 2001.003.1/64 and no shutdown. And in router 3, interface fast Ethernet 1/1, IPv6 address 2001.003.2/64 and no shutdown. Let's check our connectivity between these two routers. Ping 2001.003.1 and the connectivity is okay. By now I just configuring IPv6 addresses on the interfaces. Therefore, I do not expect to ping, for example, router 3 or router 2 interfaces from my PC because the routing infrastructure is not complete yet. Just for testing, I ping 2001.003-1. Let me put -6 here to inform Windows that I want to ping an IPv6 address. And as you could see, there is no IP connectivity between my host and router 3. And now I want to configure IPv6 routing and form the IP connectivity between these networks. By default, IPv6 routing is not enabled on routers. Therefore, first of all, we have to enable IPv6 routing. This is done by the command IPv6 unicast routing. With this command, IPv6 routing is enabled on our router. The second step is enabling EIGRP. This enabling is done through IPv6 router EIGRP and the AS number. IPv6 router EIGRP and AS number. Now IPv6 routing on EIGRP is enabled on our router. And we are entering config-rtr in command prompt. If I put the question mark here, you see that there is no any network command. We don't have network command in EIGRP for IPv6. Instead, we have to enable EIGRP directly on our interfaces. Therefore, I select my interfaces. I have to exit from this mode. Interface fast Ethernet. Let me show my interface labels. Router 1. Interface fast Ethernet 0/0 and IPv6 IPv6 EIGRP 1 and the other interface fast Ethernet 1/0 interface fast Ethernet 1/0 and IPv6 EIGRP 1. Let's do it on other routers too. First of all, IPv6 unicast routing, then IPv6 router EIGRP 1 interface. This is on router 2. Interface fast Ethernet 1/0 and IPv6 EIGRP 1. And on router 3, let me clear the screen. IPv6 unicast routing, and now IPv6 router EIGRP 1 interface fast Ethernet 1/1 IPv6 EIGRP 1 Okay, everything seems okay. After enabling EIGRP globally on the router and on the interfaces, we have to set a router ID for EIGRP for IPv6. Router ID is the router identity or router identification in EIGRP infrastructure, and each router should have one of them. Router ID could be set in three priorities. First of all, the network administrator could set it with router ID command. Router ID is in the IP address format, IPv4 address. It is not the IP address of our router, but the format of the router ID is just the same as IPv4 address. For example, 1.1.1. If the network administrator does not set the router ID with router ID command in router submode, iOS looks for loopback interfaces and set the IP address of the loopback interface, which is the IP address of the loopback interface, as the router ID. If there is no any loopback address, iOS looks for interfaces which are in up state and choose the biggest IP address of these interfaces. For example, if we have three interfaces on our routers with 192.168.1.1, 2.1, and 3.1, iOS chooses 3.1 as the router ID. This is because we didn't set the router ID in EIGRP for IPv4. The iOS selected itself. But in IPv6 and in our infrastructure, because we don't have any IPv4 addresses on our routers and we don't have any loopback addresses, we have to set our router ID by ourselves. Otherwise, EIGRP won't work. So let's configure router ID on our routers. For selecting router ID, we have to go to router submode. Therefore, I type IPv4 EIGRP, router EIGRP1, and set EIGRP router ID 1.1.1.1, and do it for router 2, IPv6 EI router EIGRP1, EIGRP router ID 2222, and in router 3, IPv6 router EIGRP1, EIGRP router ID 3.3.3.3. Now I hope everything would be okay. Let's start our troubleshooting commands. If you remember that we have tested 5 troubleshooting commands in the previous lecture. Show IP EIGRP interfaces, show IP protocols, show IP EIGRP neighbors, show IP EIGRP topology, and show IP route. These commands are the same for EIGRP for IPv6, except that IP is substitute with IPv6. I mean, if we have show IP EIGRP interfaces, now we have show IPv6 EIGRP interfaces. Let's test it. Show IPv6 EIGRP interfaces. You could see which interfaces are EIGRP enabled. We have show IP protocols in EIGRP for IPv4. Here we have show IPv6 protocols, and you see that EIGRP is enabled on this router with these parameters. We have show IP EIGRP neighbors, and now we have show IPv6 EIGRP neighbors, and you see that the link local address of the neighbor is presented here, as we mentioned before. Show IP EIGRP topology, substitute with show IPv6 EIGRP topology, and we could customize it for a special network. For example, topology 2001 001/64, and you see the same parameters as we had it for EIGRP for IPv6. And finally, show IPv6 route, and it shows us the IPv6 routing table of our router. Router has 2 routing tables for IPv4 and IPv6. Show IP route will show us the IPv4 routing table, and show IPv6 shows us the IPv6 routing table. And we could customize this command 2, which show IPv6 route EIGRP, and you see that only EIGRP routes are presented here. One more tip: if you see that you do all these configurations and when you type show IPv6 EIGRP interfaces or any other troubleshooting commands and the prompt shows you that EIGRP is shut down, just go to the router subcommand mode IPv6 router EIGRP, for example, EIGRP1, and just say no shutdown to exit the EIGRP from shutdown mode. It may be a problem that you confront with it. Now let's check our connectivity from host 1 to other routers. If I select command prompt and say ping 2001.0.0.1.2, you see that we have connectivity. Let's check 22, which is router 2 IP address. We have the connectivity. And 32, we have the connectivity. Everything seems to be okay. And we are done in this lecture. Now it's summary time. In this lecture, we learned the similarities and the differences between EIGRP for IPv4 and EIGRP for IPv6, and we configure EIGRP for IPv6 and use some troubleshooting commands. I hope this lecture helps you to improve your knowledge, and see you in the next lecture.